Welcome to lesson 5.2, linear and nonlinear functions. Our objective for today is to distinguish between linear and nonlinear equations. Okay, so flip the page for me. So a linear function. Well, in linear, we see the word line, right? And what that means is when we graph a linear function, it's going to create a line. So when graphed, it is a line. Well, so that means that if it's a line when it's graphed, it has to be in my slope-intercept form, right? Because that's what we've been doing with lines all this time. So it's of the form y equals mx plus b, right? So it has a slope and a linear function has a y-intercept, right? It's just a line. So remember that m is our slope and b is our y-intercept. Okay, so a linear function is a function that when it's graphed is a line with a slope and a y-intercept. Okay, so a nonlinear function, you guessed it, it's a function that when you graph it is not a line. Pretty easy, right? So when graphed, it does not create a line. Well, what does this mean, right? Sure, we can look at a graph and say, hey, that's not a line. But what if it's in a different form, like a table or a set of ordered pairs, right? Instead, remember, slope is a constant rate of change, right? So in a nonlinear function, they do not have a constant rate of change, okay? They do not have a slope that exists that's the same every time. So remember, with a linear function, when we're graphing a line, we always go up the same amount and then over to the right the same amount when we're graphing it, right? Rise over run is the same every time. With a nonlinear function, that's not the case, okay? So when graphed, it's not a line. For nonlinear, linear functions are a line when graphed. So looking here, it says state whether each graph is linear and nonlinear. Piece of cake, Miss Wall. Does this look like a line to me? No, so this is nonlinear, right? This is actually called the parabola. And notice it has two y-intercepts, not just one. That's important. Now here we see that it's a line, so it has to be linear. In fact, it's a decreasing line, right? And we could always find the equation of the line if we wanted to and we're eager. Yeah. Same thing for C. C is a linear function because it creates a line when graphed. So it's going to be a linear function here. All right, so I want you to take a minute to do D, E, and F. Tell me whether they're linear or nonlinear for me, and then flip the page. All right, welcome back. So let's see. Number 2 says state whether the following equations are linear or nonlinear. So remember, linear functions are in our y equals mx plus b form. That's if they are linear, right? I can create the equation of a line if they're linear. So looking here, we need to make sure, first of all, that whenever we have a function, if it's linear, the exponent on the x is a 1, right? X raised to the first power is x. So that's important here, okay? So looking at A, is A in the form y equals mx plus b? Well, it has this squared here, right? And x has to be to the first power in a linear equation. So no, this is nonlinear. Looking at the second one, y equals mx plus b. Yeah, that's in slope-intercept form. So that means it is a linear equation. It does graph to create a line. And in fact, our slope is 3 and our y-intercept is 5. Looking at C, y equals 4x minus 6. Looks a lot like y equals mx plus b, right? Our slope is 4, y-intercept is negative 6, so it is a linear function. Looking at D, this one might trip you up, but this is really in slope-intercept form, right? It is the equation of a line because negative 1/4 is our slope and 2 is our y-intercept, so it is linear. This next one, we have y equals x squared plus 5x minus 2. Well, this looks linear to me, but I don't remember ever seeing an x squared before in a linear equation. So that is nonlinear. And last but not least, looking at y equals 2 to the x power. When has x ever been in the power of 2? That's crazy talk. That's never going to create a line. So this is going to be nonlinear as well. Okay, what I would like you to do is take a moment for me and to do all of these right here. So start with y equals 1 over x and end with y equals 3x plus 1. State if they're linear or not linear. Please raise your hand to get it checked when you're done. All right, welcome back. Let's take a look at 2. I wanted to emphasize this question says which equation does not represent a linear function. So looking at these, which one is not a linear function? Well, here we have y equals negative 3/4 x. Really, there could be a plus 0 there, right, for our y-intercept. So that's in the form y equals mx plus b. So that's linear. Here we have y equals x over 2. Well, x divided by 2 is the same thing as x times half. So is y equals 1/2 x. If I graph that, is that in slope-intercept form? Will that be a line when I graph it? Absolutely, right? My y-intercept is 0. My slope is 1/2. So that's linear, which means it's not my choice. Here, y equals mx plus b. Well, I have an mx and I have a b. They're just kind of out of order. So that's okay. That is linear. So here, looking at this next one, we see that D is not linear. And the reason why is because it has an exponent of 2, which is exactly what we wanted because it says which one does not represent. Okay? So go ahead and flip the page for me. All right, your job next is to tackle these multiple choice questions, the entire page. 1, 2, 3, 4. All right, work on these 4 multiple choice questions. Please raise your hand to get it checked before you move on. All right, welcome back. On these next 3, I would like you to take a look, tell me the answer to these 3 here. Make sure in your explanation for this one on whether it's linear or not, tell us why in the explanation. Okay, and then when you're ready, get this whole page checked, and then you can move on. All right, so we've seen linear and nonlinear functions in graphs, and we've seen them in equation form, right? Y equals mx plus b form, but we haven't seen them yet in tables to decipher whether they're linear or not. So remember how when I was talking back in the beginning about linear functions have to have a constant rate of change. Okay, they have to be going rise up and then run over the same amount every single time. They have to have that slope that's consistent. So here we have to check and see in our table whether our slope is consistent every time. So looking at the first one, A, remember when we find our slope, we do the change in y over the change in x. So looking at this, I have 2 goes to 4, well that's plus 2. 4 goes to 6 plus 2. And 6 goes to 8 plus 2. So my y's are changing the same every time. Every time I'm going up 2. Now my x's, it looks like 3 to 5, I'm going up 2. 5 to 7, up 2. 7 to 9, up 2. So my change in y's is 2, my change in x is 2, and it's consistent on both. So is it a linear function? Yes, it is. Right? Because in fact, my slope, my constant rate of change is 2 over 2, which is 1 in this case. Okay, looking at B, y from 2 to 4, I go up 2. From 4 to 8, I go up 4. And 8 to 16, I go up 8. Looking on my x's, it looks like I go up 1 each time. 2 to 3 is up 1. 3 to 4 is up 1. Right? So here, my x's are constant, but my y's are not, which means that it's not linear. They have to be changing at the same rate on the y's and the same on the x's. Okay? So looking at this next one, from 14 to 30, I go up 6. From 30 to 46, I go up 6. But from 46 to 62, that's way more than 6, right? Let's see, that's 14. And here on my x's, I go up 4, and up 4. So let me zoom in on that for you for a minute. So I'm not going up the same rate on my y's as I am my x's. So this is not linear, because if this was a 6, then it would be linear, because all of my y's are changing by the same and all of my x's are changing by the same, respectively. Okay? Looking at the next one, my change in y from 6 to 11, I go up 5. 11 to 18, I go up 7. 18 to 27, I go up 9. They're not the same at all. There's no way. And on this side, they all go up by 1. So because this goes up by 1, but this one does not go up the same, it is going to be nonlinear. Okay, so I would like you to work on E, F, and G for me. Please raise your hand to get it checked when you're done. E, F, and G. Bye.